As we gaze into the vastness of space, watching the twinkling dance of billions of stars, a timeless question echoes through the cosmos. Are we truly alone? For centuries, humans have looked up at the night sky, wondering if somewhere, far beyond our solar system, another world might harbor life. Every star, every distant planet, holds the promise of a mystery yet to be solved. Now, with the launch of the James Webb Space Telescope, humanity has a tool capable of peering deeper into the universe than ever before. Acting like a powerful magnifying glass, JWST can reveal details of distant planets that were once unimaginable, allowing scientists to study their atmospheres, climates, and even potential signs of life with unparalleled precision. Recently, JWST turned its gaze toward a remarkable target, K2-12B, an exoplanet located approximately 120 light-years away in the constellation Leo. From the moment the first observations were received, excitement spread rapidly through the scientific community. K2-12B is not an ordinary planet. It shows signs of water vapor in its atmosphere, a critical ingredient for life as we know it, and scientists have also detected traces of a molecule known as dimethyl sulfide, DMS. On Earth, this molecule is almost exclusively produced by living organisms, primarily microscopic life in the oceans. Could this distant world really be exhibiting signs of biology? Could this be the moment when humanity finally discovers that life exists beyond our pale blue dot? K2-12B belongs to a class of planets known as sub-Neptunes, worlds larger than Earth but smaller than Neptune. These planets do not exist in our solar system, making them especially intriguing. They defy our traditional categories of planets and challenge scientists to expand their understanding of planetary environments. While rocky planets like Earth and Mars provide familiar points of comparison, and gas giants like Jupiter and Saturn offer insight into massive atmospheres, sub-Neptunes remain largely mysterious. Their size, composition, and structure suggest a range of possibilities that could make them prime candidates for habitability and even for hosting life. K2-12B orbits its host star, a cool red dwarf known as K2-18, at just 0.18 astronomical units. Much closer than Mercury is to our Sun. Despite this close proximity, the planet has not been scorched. Red dwarfs emit far less heat than stars like our Sun, creating conditions that might allow water to exist in liquid form. A single year on K2-18B lasts only 13 Earth days due to its tight orbit, meaning the planet experiences rapid cycles of day and night. Yet, thanks to the star's lower luminosity, temperatures may remain within a range suitable for life, allowing water vapor to persist in the atmosphere. This delicate balance makes K2-18B a unique laboratory for scientists to study planetary climates, chemical compositions, and the potential for life. Using JWST, astronomers studied K2-18B via transit spectroscopy, a method that observes the planet as it passes directly in front of its star. As the star's light filters through the planet's atmosphere, it carries with it a chemical fingerprint, revealing the composition of the gases above the surface. By separating the light into its individual wavelengths, scientists can detect specific molecules, including water vapor, methane, carbon dioxide, and, most intriguingly, dimethyl sulfide. On Earth, DMS is produced almost exclusively by living organisms, primarily microorganisms in the oceans. Its detection on K2-18B suggests the tantalizing possibility that life might exist there, though further verification is necessary. K2-18B's atmosphere is believed to be rich in hydrogen, which may trap heat and create stable conditions for liquid water to exist beneath its clouds. Some models suggest that the planet may be a Hycean world, a newly proposed type of exoplanet with massive oceans and thick hydrogen-rich atmospheres. These planets could have oceans making up to 90% of their mass, potentially covering the entire surface. While surface temperatures may reach around 200 degrees Celsius, the dense atmosphere and deep oceans may provide stable environments where life could thrive. On Earth, extremophiles, organisms surviving in boiling hydrothermal vents, Antarctic subglacial lakes, and highly acidic environments, show that life can exist under extreme conditions. Could similar lifeforms survive beneath K2-18b's oceans? The possibility is thrilling and challenges our understanding of what life requires. The potential detection of dimethyl sulfide is particularly exciting because, unlike methane, which can be produced both biologically and geologically, DMS is a molecule almost exclusively associated with biological activity. If confirmed, it would mark the most compelling evidence yet that life may exist elsewhere in the galaxy. However, scientists proceed with caution. The JWST's data must undergo rigorous analysis, and future observations will be needed to confirm whether DMS truly exists in K2-18b's atmosphere or whether it could be produced by unknown chemical processes. Regardless, this discovery has already revolutionized the search for life beyond Earth. K2-18b demonstrates that planets vastly different from our own may still harbor life-friendly environments. Sub-Neptunes, like this Hycean world, are relatively common throughout the Milky Way, and their size and thick atmospheres make them easier to detect than smaller, rocky exoplanets. Their oceans could provide the conditions for microbial life, while their atmospheres may protect them from harsh radiation. These characteristics make them ideal targets for telescopes and a key focus of exoplanet research. Studying K2-18b is a meticulous and challenging process. Even with the JWST's advanced capabilities, capturing data requires careful planning. For the detection of water vapor and dimethyl sulfide, astronomers used more than 5 hours of telescope time, spread across multiple observing sessions to capture the planet during its transit from different angles. Each photon of starlight is analyzed, gradually building a detailed picture of the planet's atmosphere and environmental conditions. K2-18b is not the only world in our solar neighborhood or beyond that hints at the possibility of life. Moons such as Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, are believed to host subsurface oceans beneath icy crusts, with hydrothermal activity that could provide energy for microbial life. Even distant planets with hydrogen-rich atmospheres, like K2-18b, expand the number of locations where life could exist, suggesting that the universe may be teeming with worlds capable of supporting living organisms. The discovery of water vapor, potential biomarkers, and unique atmospheric features on K2-18b provides insight into a planet that challenges our understanding of planetary science. Whether or not life exists there, K2-18b offers a tantalizing glimpse into what may be possible elsewhere in the universe. Its oceans, thick hydrogen atmosphere, and potential biological markers inspire scientists and dreamers alike to continue the search for life. As we continue to observe K2-18b, each new detail adds depth to our understanding. Its proximity to a red dwarf star, its short orbital period, and the chemical composition of its atmosphere all contribute to a complex, fascinating picture. It is a planet that seems almost alien in nature yet holds features that could make it surprisingly familiar in terms of habitability. Perhaps one day, distant probes or advanced telescopes may reveal even more about this ocean world, its oceans, and the possibility of life thriving beneath the clouds. So, what do you think? Could K2-18b be humanity's first glimpse of life beyond our own planet? Or are we witnessing natural processes we do not yet fully understand? Let us know your thoughts in the comments below. If you enjoyed this journey into the unknown, remember to like, share, and subscribe to Waves Discovery, where we explore the mysteries of the cosmos, one extraordinary discovery at a time. The universe is vast, strange, and full of surprises, and K2-18b is only the beginning of the story.